Hello, chemists. Here with Chemistry Cat. The noble gas joke I heard was so funny, I slapped my knee on that one. Isn't he clever? So I hope you have your Boyle's Law notes handy and a calculator. And if you watched the little video that I had assigned to you, you would know that Boyle's Law has to do with volume and pressure. And we're going to maintain a constant temperature and have a fixed amount of gas that doesn't change. So if we increase the pressure, the volume actually decreases, or vice versa. If we decrease the pressure, the volume will increase. So our formula for Boyle's law is pressure 1 times volume 1 equals pressure 2 times volume 2. If we know any of the three variables, we can solve for the fourth variable. So this picture here comes right out of your textbook. We have three scenarios. Each is a cylinder that has a piston on top and a certain amount of gas inside of the cylinder. Here we have atmospheric pressure just pushing down on the piston, and atmospheric pressure is 1 atmosphere. And the temperature in each of these is 25 Celsius. It doesn't change. Look at the volume that the gas takes up, 10 liters. If we push down with more force on this piston and we push down with a pressure of 2 atmospheres, then the gas inside is pushing back with a pressure of 2 atmospheres. Look at what happened to the volume. All those little gas particles that got squished down, volume got cut in half. It went from 10 liters to 5 liters. If we push down on the piston again and we double that pressure to 4 atmospheres, the volume gets cut in half again. So every time you push down and double the pressure, the volume gets cut in half. So we have an inverse relationship happening here. As the pressure goes up, the volume goes down. So in our first example, the pressure of a gas in a 275 milliliter container is 1.20 atm. What's atm stand for? Atmospheres. And that's our initial pressure. Here's our initial volume. What is the new pressure if the gas is transferred to a 500 ml container? Well, that's our second volume. The first thing that we want to do is list our given. Which are the known variables and their values. So the 275 milliliters, that's our V1. There we go. V1 equals 275 milliliters. V1, our initial pressure, equals 1.20 atmospheres. P2 is what we don't know. That's our unknown variable that we're trying to solve for. And V2 equals 500 milliliters. So here we've listed our given. It'll make it real easy to locate whenever we want to put it into our formula. So Boyle's law formula, V1 times V1 equals V2 times V2. We're going to rearrange this formula to solve for our unknown variable, which in this case is pressure 2. So what I need to do now is if I want to get pressure 2 by itself, I need to undo multiplication happening between it and volume 2. So I'm going to divide by volume 2, and what I do to one side, I do to the other. My volume 2 cancels off here, and look, I've got P2 equal to pressure 1 times volume 1 divided by volume 2. And now I can substitute in to this formula my known variables with their units and solve for pressure 2. So my first pressure, 1.20 atm, times volume 1, which is 275 milliliters, divided by volume 2, which is 500 milliliters. And what is the unit that is going to cancel off and go away? Milliliters. So in your calculator, you want to take 1.20 times 275 divided by 500, and that gives us our answer for pressure 2 as 0.660 atmospheres. And that is the answer that we're after. So this is what I'm going to be looking for, that you've listed the given, that you have your formula rearranged for the unknown variable that you're trying to solve for with all of the known variables on the other side, that you're showing all of your work with proper units, and that you have your answer with the proper unit. So that's what I'm going to be looking for. So let's move on to our next example. A gas has a volume of 2.5 liters when measured at a pressure of 98 kPa or kilopascals. If the temperature is not changed, what would the volume be at standard pressure? Well, take a look here. Standard pressure, we are working with kilopascals, and standard atmospheric pressure is 101.3 kPa. So that is our second pressure. That is P2. So the first thing we want to do is list our given. So our volume 1 is 2.5 liter. Our pressure, P1, is 98 kilopascals. We don't have to worry about temperature. It tells us it's not going to change, so we don't bother to even put it down. What would the volume be? P2, that's what we're trying to solve for. And P2, standard pressure. Well, since it's kPa, it's 101.3 kPa. And you know what your formula is. Now, it really doesn't matter if you write P1 times V1 equals P2 times V2, or if you write volume 1 times pressure 1 equals volume 2 times pressure 2. It really doesn't make any difference. So what we're going to need to do is, divide. Okay, we want to get V2 by itself, so we need to divide both sides by P2. So we're left with V2 equals pressure 1 times volume 1 over pressure 2. And we would get the exact same rearranged formula even if we put the swap the V1 and the P1 and the V2 and the P2. Okay, because we would still want to get V2 by itself, so we would divide both sides by P2. And P2 would go away. And see, we've got V1 and P1 on top, V1 and P1 on top, and P2 on the bottom. So now all we have to do is just substitute in pressure 1, 98 kPa, multiplied by volume 1, 2.5 liters, divided by pressure 2, 101.3 kPa. And kilopascal units cancel out. Put this into your trusty calculator and see what you get. 98 times 2.5 divided by 101.3 gives us 2.4 liters. Okay, so think about this. If you take a look at your data here, it makes sense that the volume should decrease, right? Because pressure went from 98 to 101.3. So it would stand to reason that volume should actually go down, and it did. It went from 2.5 liters down to 2.4 liters. Okay, so don't forget to submit your notes, complete your worksheet, and have a great day.